Welcome to Chapter 9, Writing Equations of Circle and Ellipse. So I know we now have circles, ellipse, hyperbolas, and parabolas as our known conic shapes. We're now going to take a step back and review how to write equations of circle and ellipse given a variety of information. First example is write the equation of the circle with the given information. Okay, I'm going to draw a picture just because that's helpful to me. The center is -1, 2, and it's tangent to the y-axis. So it means it's going to go like that. Oop, yeah, good enough. Okay, tangent to the y-axis, that vertical axis. Well, because I already know the center and I know it's a circle, I can write the beginning of my equation just like that, right? The opposite of what's in the equation. Now I need to find the radius. Well, luckily I'm given the center, and if it's tangent, that tells me that it's going to cross at that point. Well, that gives me then my radius is 1 unit away. So radius is 1 squared, or you can just put 1, and then you have your circle equation. Alright, so circles are pretty nice. Again, just make sure you have the radius squared. In this case, because it's 1, it doesn't really matter. Now, when we go to ellipses, there's a little more information and a little more area you need to watch out for. So again, I'm going to draw a picture just because that's helpful to me. Go like that. I know the vertices are 8, -2, so 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, and -6, 1, 2, 3, 4, 5, 6, -2, and then the length of the minor axes is 8. Okay, well, I know these right here are the vertices. Because I'm in an ellipse, I know that this axis then, from those 2 points, is going to be my major axis. So a couple information to write down is the fact that this right here is the major axis, and the major axis equals 14, right? 14 units between the 2 axes. Then the minor axis is 8. Well, I know it's going to have to go through the center point, so let's find that. That's important. The center, if the major axis is 14, will be 7 into the middle. So 1, 2, 3, 4, 5, 6, 7, right here. That's going to be my center. So I'm just going to, as I know stuff, write it down. So the center is going to be the point 1, -2. And now I know from there, that's where my minor axis is going to happen. It has a length of 8, so that means it's 4 up, 4 down. 2, 3, 4, so that would fall right here. 1, 2, 1, 3, 4, right there. So these are my other vertices. Okay, so here's my shape. Again, you don't have to be doing all this work. I just think it's helpful to look at that weird looking ellipse. Now, if my center is 1, -2, I can begin setting up my equation. I know it's going to be, oops, don't want that. Go back. It is going to be x minus 1 squared. It's an ellipse, so make sure you have your plus in between. It's going to be y plus 2 squared. It's going to equal 1 because it's an ellipse. And now I need to find my denominators. Well, under the x is going to be the rx. So what distance do I go in the x direction? Well, that's easy. That would be from here to here. So my rx is 7. Notice what goes on the bottom is rx squared, hence 49. Then finding the y direction would be just from here to here. So ry equals 4. And again, you don't just put 4, you put 4 squared, which is 16. So there is your equation of an ellipse if you know the vertices and the length of the minor axes. Okay, one more. This time you're given the length of the major, and now you're given your foci. I'm going to draw a picture. So foci is 1, 2, 3, -3, and 1, 2, 3, 1, 2, 3, 4, 5, here and here. Okay, so those are my foci, which have to be inside my ellipse. I'm also given the length of the major axes is 12. Well, that means my foci are going to be on the line x equals 3, because it needs to be on the same line as my foci. But I don't know where to start. I mean, it is 12 units long, but I need to first find my center. Well, it's going to be in between my foci, right in between. And because my foci are 1, 2, 3, 4, 5, 6, 7, 8 units away, I know it's going to be 4 inwards. So it's really going to fall at 3, 1 is my center. So again, as soon as I know something, I'm going to write it down. Center, 3, 1. Well, that's really helpful because the major axis is 12, so I need to go 12 as my total length. So 6 above, 6 below. 1, 2, 3, 4, 5, 6. Okay, so there's a point here. 1, 2, 3, 4, 5, 6. Oops, yep. Here are my vertices. Okay, so that's all I know. I'll write those out too, just so that, in case you can't tell on my graph. But my vertices are 3, 7, and 3, -5. Now, the big thing I'm missing is my Rx. How actually stretched out is my graph? Well, think back to ellipses. We deal with the equation of foci. F squared equals your Ry squared minus Rx squared, or whichever one will be positive. Well, since I know my major axis is 12, that's the longer one. So I'm going to use the formula for foci of F squared equals Ry squared minus Rx squared. Again, you're in ellipse, so that's why you're subtracting. Now, I actually know my focal length. I'm actually using this formula to find my Rx. A little bit different, same formula. F squared. Well, that's this distance here from center to a focus. Well, F, that distance is 4. Right, we already knew that. So F squared would be 16. Ry, same idea. Ry is just this distance here. Ry from the center to the major vertice. Well, Ry we already know is 6. So this would be Ry squared, 36. And we're subtracting Rx squared. This is what we're trying to find. Again, we're using this formula just to find how wide your ellipse is. So doing some math, I get negative, wow, I did not expect that to happen. You get -20 to equal your negative Rx squared. So Rx squared equals 20, just divided by -1. And that's really all I want. I don't need to find Rx. I mean, you could, but you really don't need to. This is what I want. Because when I write my equation, let's think about it. You have your center, so x minus 3 squared You're an ellipse, so addition. I'm going to move over a tad so I have a little bit more room. You have addition. It's going to be y minus 1 squared. It's going to equal 1 because it's an ellipse. And now we know our denominators. How far do we go in the x direction? Or what is rx squared? Well, we know that now is 20. We know that our ry is 6. So 6 squared, 36. And just like that, we have our equation of our ellipse. Please make sure you look through all the homework problems. We're going to give you a little bit of variety for each shape. Drawing out is a fabulous idea to get you started. If you have questions, please ask. Otherwise, good luck.